Hello and welcome. In this video, we are going to start our introduction to vectors. And specifically, we're going to be looking at numeric vectors, which can also be thought of as one-dimensional arrays in Matlab. This video assumes that you've watched some of the earlier videos talking about the Matlab integrated development environment. We won't go into a lot of details as far as the IDE, but rather we're going to focus in on how to create and then ultimately access vectors manually. So to begin with, what we want to do is we want to start off by opening up our web browser and perhaps bookmarking the URL that I have here. This is part of a tutorial that Matlab provides, as well as some documentation. We're not going to be following that strictly. Instead, what we're going to do is we're going to focus on the vector or one-dimensional variants of the arrays. And then in later videos, we'll start taking a look at 2, 3, and maybe even multiple dimensional arrays. So to begin with, what is an array? Well, to understand what an array is or a vector, you have to understand what a single value was. And if you recall from our first videos, we did something like this, where we specified a equals to 1, and we just assigned 1 to the newly created variable. I optionally included the semicolon. We'll talk more about when you would include the semicolon or not include the semicolon later on, but effectively all this does is it suppresses the output on the command window. And to understand real quick how that works, I'm just simply going to highlight this line of code, and you'll see that Matlab doesn't produce anything on the console other than simply what I've done here is I've essentially just copied and pasted the command into the command window and ran it. You'll notice over on the workspace, then I have my variable a equal to 1. Now, if I were to remove the 1 and rerun this, you'll see that in addition to copying and pasting the command into the console or the command window, it sort of parrots back the value. In other words, it gives you a confirmation that something has in fact happened. Well, these are what are referred to as scalar or singular values. And I'll probably use these terms interchangeably. Oftentimes, you can think of scalars as from your math or your physics course as just a single value, perhaps from your calculus course, the coefficient in front of a y equals to f of x function, and so on. All right, so what is a vector? Well, a vector is simply just a collection of scalar values, with the most important detail being that they must be all of the same data type. Now, we haven't really emphasized data types yet. However, for this particular example, I'd at least like to point out that if you come back over here to the workspace, you'll see that in addition to the name, value, and the size, we also have the class. And if you've not yet added that, then make sure to right-click on the column headers and add the class. The class I will also refer to as the type or data type. And in this case, the default numeric data type for Matlab is double precision. Again, we'll take a more in-depth look at the different data types and the advantages and disadvantages of each of them in a later video. But for right now, you can just rest assured that if it is a numeric value, then it is more than likely going to be of type double. Now, a vector is just simply a collection of scalars or a collection of values. And in this case, we are going to focus on the double data type. Now, I'm being very careful about how I word the collection. In other words, the collection implies that there is something in common, and in this case, it's the data type. However, I'm not going to use the word sequence or set or anything like that, because then that implies some relationship between the values in a vector. For instance, if I say that it's a sequence of values, then automatically in your mind, you're probably going to think that I'm starting with 1, 2, 3, and then so on. However, the only thing that you can be guaranteed of with a vector is that they are of the same data type. Now, a little bit of a spoiler alert, this is true for arrays as well. In a later video, we'll take a look and we'll see data types that will actually allow for you to store variables or values of different data types. But for right now, we are going to assume that they are homogeneous. Well, enough talk about what they are. Let's see how we actually go about creating them. And so in this case, I'm going to just simply use another variable here. We're going to call this a b, and we are going to manually create them. Well, in order to be able to manually create them, we simply use our square brackets, and then we start off essentially just specifying the individual scalar values. Now, for this first example here, I am going to give you a sequence of values, in this case, 1, 2, 3, 4, 5. However, we can also do something like this, 5, 4, 3, 2, 1. And for that matter, there doesn't have to be any sort of order at all. So let's do 5, 3, 2, 4, 1, and so on. And you'll notice here, I'm intentionally leaving off the semicolon. We'll see what effect that has in just a second, but we're going to highlight, and then we are going to evaluate that single line, and you'll see that now we have a new variable in the workspace. It is of class double, and it is of size 1 by 5, and there are our values. And as a matter of fact, you can just simply click on the variable b, and you'll see that there are the individual elements in the vector, starting with 1, 2, 3, 4, and 5. Now, if I were to have added the semicolon here and run this highlighting F9, you'll simply see that there is less noise in the command window. And again, for right now, it doesn't really matter whether you do or do not use the semicolon to suppress the output, but we will talk about when you would want to do that in later videos. So at this point, then you can see the same thing will happen with our C, likewise with our D, and you can see that I'm just basically filling up the workspace with, quite frankly, some very poor variables, variable names, that is. In other words, you probably would not want to use the variable names of A, B, C, and D. I'm just wanting to keep this example simple. Now, there is nothing magical about 5 values. In other words, you can simply have some fun with this. They also can be negative. I have kept it to integer values. However, there is no requirement for that either. So in other words, you might have a 3.14 in there, maybe a 0.5. We can even go so far as to actually put a calculation in there. So how about 1 divided by 3? And then for that matter, we can actually put a function in there, function or constant, however you want to think of the pi behavior in Matlab, as well as, again, plenty of other values here. So we're going to go ahead and include a negative 0.25 just to mix things up a little bit. And how about another value here, 10.2? And one of the things that you're going to discover is that humans make for pretty lousy random number generators. And so you can see here that basically I'm just trying to prove then that in this case, we have a 1 by 7 vector. Notice that the class is double, the data type is double. However, though, some of these values, at least initially, appear to be both integers as well as rational and irrational values. And so again, these are all going to be stored as the same data type. If you know a little bit about data types or memory storage in general, you'll know that you don't necessarily need to have double precision when you store integers. Again, we will focus on data types in a later video. Now, you'll notice here that every single one of these vectors that I have created are effectively one row. In other words, these are row vectors. There's probably going to be a way to create a column vector, right? And there is. And it's a little bit different of a syntax, but again, you simply start off with the square brackets. And this time around, what we're going to do is after each one of the values, I'm simply going to specify a semicolon. Now, I'm going through the trouble in this particular example to line these up just so that you can see how this would work. However, what you're going to discover is that as long as the semicolon is present, you don't actually have to do that. But first, let's go ahead and run this one, and you'll see that I now have a 5 by 1 column vector. As a matter of fact, if I click on my F, you'll see that there they are, 1, 2, 3, 4, 5, now all arranged in a nice column. And to give you an alternate way to create this. You can also see here, we're going to do this little countdown vector from 5, 4, 3, 2, 1. And again, this is going to have the same result. It's going to create a 5-row, 1-column vector, or a column vector. And notice that the way that I wrote this does in fact not matter, meaning that the white space or the new lines between each of the elements actually doesn't matter. This is just for readability's sake if you choose to do this. And by the way, I should point out that you're probably not going to find yourself creating vectors manually all that often. It is just something that you need to know how to do, because occasionally you will want to do this. And again, humans make for bad random number generators, so it's not going to be real easy for us to show larger and larger vectors. In other words, for instance, if you had asked me to create a vector of 100 random values, it can almost be guaranteed that those values will be in no way random. The last thing that I want to show you is an alternate way of creating a row vector from a column vector, and likewise a column vector from a row vector. And so what we're going to do is we're going to take our initial F vector, which was a row vector, and we are going to turn it into a column vector. And the way that we do this is we are again going to use another very poorly named variable, in this case H, and we are going to use the single quote mark, which effectively corresponds to transposing a vector. In other words, all of the row values will now become columns, and all the column values will now become rows. It gets a little more sophisticated when we start looking at multi-dimensional arrays. However, though, for vectors, the net result here is that that original 1 by 5, or rather that original 5 by 1 for F, now becomes a 1 by 5. And you'll notice here that F was a column vector. As a matter of fact, we can simply come down here to our console and we can just type in the letter F and it'll get parroted back to us. Now we can type in the letter H and you'll see there is our H. So basically what we've done is we've converted a column vector into a row vector. I'm going to skip over the letter I, and the reason for it being is because I is the imaginary number. And then we'll go ahead and use the letter J here. So J, then we can just make the transpose of G. And again, remember that G is nothing more than a column vector. And sure enough, then J becomes a row vector. And then likewise, if we want to go from a row vector into a column vector, we'll simply use our letter K, and we will make it then the transpose of J. And again, you can sort of see here that maybe it's easier, or maybe you were given the values in a row vector and you need to turn them into a column vector, or a column vector back to a row vector. So that's about it for creating the vectors, but then let's talk about accessing the values in a vector. Now, what we're going to do is we're going to focus on one of the earlier examples. I like to use the C example up here because it allows for us to really delve into the difference between the value at a location and the index or the location itself. What do I mean? Well, if we come back over here and we look at the variable C, you'll notice the value at the first location is 5, the value at the second location is 4, the value at the third location is 3, the value at the fourth location is 2, and finally the value at the fifth location is 1. And hopefully you could start to see then that there is an additional component with vectors and also with arrays. That is, not only do you have a single value, but you also have to be concerned about the position or the location of that value. Well, what we can do is we can simply specify then the location that we're interested in by using parentheses. Matlab is 1-based indexing. In other words, basically the lowest index you're going to find in a vector or an array is going to be 1. And simply specifying the parentheses allows for you then to access a single value in a vector. Likewise, C2 will give you the second value in the vector. C3 will give you the third value in the vector. C4 will give you the fourth value in the vector. Lastly, C5 will give you the fifth value in the vector. Now, we will take a look at some fancy tricks that we can do with respect to vectors in a later video, but this at least gives you the start of understanding how to manually create a vector as well as access the individual elements in the vector. And before we leave this particular topic, I would like to point out one little feature in Matlab as it relates to arrays or vectors. And so if you happen to lose track of how many elements are in your vector, you can simply check here to see the behavior that if you enter in a value for an index that doesn't exist, in other words, basically this location in the vector does not yet have a value, you're simply going to get an error message. And so, for instance, if I specify a 6, or for instance, if I accidentally specify a negative value for the index, you again will simply get an error. Now, the one last thing that I want to point out is that yes, while you cannot technically access an element that has not yet been added, you can, however, very easily add a new value to a vector by simply specifying the location that you wish to add. And so in this case, let's say that rather than query or try to get the value in the sixth location of our C vector, I simply want to assign it a new value. In other words, I'm going to keep the same sequence going. So it's going to be 5, 4, 3, 2, 1, and now 0. And by just simply specifying that I want to add a 0 to the sixth location in our C vector, Matlab is perfectly fine with that. I can tell you that that is not the way many of your other programming languages will work. This is, again, another convenience feature in Matlab, but it does allow for you to create then vectors one more additional way. So again, this is just meant to be an introduction, sort of get you started on the concept of multi-value variables. In this case, we're going to be looking at vectors or one-dimensional arrays. Again, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.